Welcome back to Mr. Hassan's Math channel. I'm now going to answer question number 5 from the S1 Statistics Solomon C collection, which is also from the question 3 of my S1 endotopic worksheet number 7 on normal distribution. And the question is about the time taken in minutes T for a mechanic to service a bicycle, and tells us that it follows a normal distribution. So it's normally distributed. The time taken for the mechanic to service a bicycle is normally distributed. Sorry, the other way around. The time is such that it is normally distributed with a mean of 25 and a variance of 16. Okay, so we can see from here that the mean is 25 and the standard deviation, which we're interested in, is equal to the square root of the variance, which is 4. We have to find the probability that the time taken for this mechanic to service the bicycle is less than 28 minutes. Okay, so we need to draw the normal distribution curve. Okay, so here's a distribution curve, normal distribution curve, and this is basically the mean is right in the middle. It's symmetrical. If it's normally distributed, it's symmetrical, and the mean is right in the middle, which is 25. And we want to find the probability that the time is less than 28 minutes, which is something which is slightly more than the mean. Let me just put that in a thinner line. Okay, so that's 28 minutes. Okay, so we want to find the probability that it takes less than 28 minutes. So any time between that and up to 28. We need to find that area of this, and that will give us the probability that it takes less than 28 minutes. But what we need to do is we need to standardize this value of 28 according to how many standard deviations it is away from the mean. And we do that in order to use the tables which are on the other side here, which these tables over here, this normal distribution function table, I mean the z value here represents the number of standard deviations something is away from the mean, and the phi z part tells you the area which is to the left of that particular point. So for example, we're looking for something over here, and we need the area to, I mean the phi z will tell us the area to the left of that, which means a probability that something is less than that value. But these are z values which are kind of, you can say, standardized. This is telling you the number of standard deviations something is below the mean, or above the mean, sorry. Okay, or away from the mean. So basically here what we can do is we can standardize the value of 28. And in order to do that, what we need to do is use this formula. So the probability that the time is less than 28 is the same as the probability that z is less than, and we're going to use this formula, z equals x, which is the amount that you want to standardize, minus the mean, which is mu, over the standard deviation. That will tell you how many standard deviations this thing is away from the mean. So you're going to have 28 minus 25 over 4. Okay, so that gives you 3 over 4. So that's a probability that z is less than 3/4, which is 0.75. So I need to find the probability that z is less than, and this is now, the z value of this is 0.75. And that's what I can use this table for. Okay, so if this is 0.75, the table, when I go to 0.75, will tell me the area to the left of it, which is what I need. Okay, so let me go to 0.75. On the table, it's right over here. We can see. So if I take this value of 0.75, the z value is 0.7734. 0.7734. So I know that this is equal to 0.7734. So we can say, therefore, that the probability that the time is less than 28 minutes is equal to 0.773. I wrote it in the end to 3SF, which is normally the standard. Okay, so there we have the probability of the time that it takes is less than 28 minutes is 0.773, 77.3% if you wish, but that's fine. Now, part B. Now, part B is a question which probably you will not see in a S1 exam. In fact, it came up, something similar to this came up in an S1 exam not too long ago, and the question was cancelled, And that particular paper, you'll notice that the paper is out of 72 or 73 marks because that part of this question was cancelled. And the reason why they don't put these type of questions in S1 exams is because S1 is a paper that can be sat in when you're doing your AS, when you've done P1 and P2, or you can do it when you're doing your A2 with the P3 and P4. It's up to you. M1 and S1 are like that. So they don't require any knowledge more than P1 and P2 for you to be able to do an S1 or M1 exam. But what this requires us is to know something in P3. So my students at school, we actually did P3 and we're doing S1 with the A2 subjects. So, most of them should be familiar with this modulus function, modulus equations, modulus inequalities. But students who are doing the AS level, haven't got to A2 yet, wouldn't be familiar with it. That's why you wouldn't see a question like this in a normal S1 exam. Okay, but I'm going to answer anyway for those people who want to know how to deal with this modulus thing, so I'm going to answer it anyway. So basically, the modulus of a function means, for example, if I say the modulus of x is equal to 3, what it means is that this modulus of x equals 3 means x is 3 units away from 0 on the number line. Okay, you can think of it as its magnitude. Okay, so x is exactly 3 units away from 0 on the number line. So it could either be -3 or it could be +3. That's the value of x. So that's what modulus of x means. You just care about the magnitude of the number, not the direction. So modulus of x equals 3 means it could be either -3 or +3. Both of those are 3 units away from 0 on the number line. Doesn't matter whether it's to the right of 0 or to the left of 0. So when you say the modulus of x is less than 3, what it means is x can be anywhere closer than 3 units, okay, to 0 on the number line. So it could be between -3 and +3. Anywhere between these would satisfy this inequality, because the distance of x from 0 in all these places is going to be less than 3. If you look at the distance between here all the way up to there, it will be less than 3 units. So we could rewrite this as x is between -3 and +3. They mean the same thing. Okay, if I had the modulus of x is greater than 3, that means the opposite, that x has to be more than 3 units away from the 0. So this would be x is less than -3 or x is greater than 3. Okay, but in this case, what we have is the modulus of t minus 25 is less than 5. So what I can understand this to be, it means that t minus 25 has to be less than 5 and it has to be more than -5, if we follow the same kind of logic here. So to solve this, I have to find t in the middle by itself. So I can add 25 to all parts of this inequality. So if I add 25 to -5, I'm going to get 20. If I add 25 to 5, I'm going to get 30. So basically what we have to do is we have to find the probability that t is between 20 and 30. That's what we have to do. That's what we're looking for. So we have to standardize these scores. So let me just get my normal distribution curve here as well. So we need to find the probability that t, we know 20 is the mean. Let me just remember that, make sure. 25 is the mean. 25 is the mean, sorry, not 20. 25 is the mean, and we want to find the probability that this is between 20 and 30. Let's say 20 is over here, and let's say 30 is over here. It's exactly symmetrical actually, because the distance between these two are the same. This is 20, that's 5 units, that's 30, that's 5 units. So basically we need to find the whole of this area between these 2 points here. Now what I can see very clearly here is that the area of this whole thing, okay, is basically twice the area of just this part. It's symmetrical. And I think that's going to help me, because if I find the probability that of t being between 25 and 30, okay, if I find the probability of t being between 20 and 35, the probability that t is between 25 and 30, okay, and I multiply that by 2, that's going to give me the whole of this area. And that might make life a bit easier for me, because I know that the area less than 25 is a half of the whole area. So this would be the same as saying 2 times the probability that t is less than 25, okay, taken away from, let me write the other way around, taken away from the probability that t is less than 30. So if I find the probability that t is less than 30, that will be the area from 30 all the way back to the beginning. And I take away from that the probability that t is less than 25, which is going to be the area from the midpoint, 25, all the way back to the end, which is going to be 0.5. I know that, it's half the area. And I multiply that by 2. I've got this whole area. The reason I'm doing that, I could have said the probability that p is less than 30 minus the probability that t is less than 20. Okay, but finding the probability that t is less than 20, it's not such a big deal. Okay, it's not such a big deal, but it's something which, you know, is a bit more work. I know the probability that t is less than 25 is a 0.5. So if I find the probability that t is less than 30, take away the probability that t is less than 25, I've got this area. All I have to do is double it, and I've got the area that I need, because this is symmetrical, because this is exactly the same, you know, distance from here as this, 5 units, 5 units. So it's completely symmetrical. So that will be easier for me. So all I have to do now is standardize these scores. So this is like 2 times the probability that that z now is less than, now I'm going to have 30 minus the mean, which is 25, divided by 4, that's going to be 1.25. So if I want to get t equals 30, that means z is going to be 30 minus 25 over 4. Okay, because that's the score minus the mean over the standard deviation. That's going to give me minus 5. That's going to be 5 over 4, sorry, which is 1.25. The probability that z is less than 1.25 minus the probability that z is less than 0, because this is the mean. Okay, if I try to standardize the mean, I'll get 25 minus 25, which is 0 over 4, which is 0. So I know that the probability that z is less than 0 is equal to 0.5. So I've got 2 times something minus 0.5. I need to find what this probability is, that z is less than 1.25. That's where I go back to my table, and I go to 1.25 this time. 1.25, where's 1.25? It's right over here, 1.25. Okay, so 1.25 is over here, which is 0.8944. So I'm looking for that value, 0.8944. Okay, so I go back to where we were. So this is 0.8944. And if I subtract these and multiply by 2, I get my answer. So I have 2 times 0.8944 minus 0.5, and that gives me my answer, which is 0.7888. 0.7888. So we can say, therefore, the probability that the modulus of t minus 25 is less than 5, is equal to 0.789 3SF. Okay, so there's the answer to part B of this question, and now we're going to go on to part C. It says, one afternoon the mechanic has 3 bicycles to service. Find the probability that he will take less than 23 minutes on each of the 3 bicycles. So let me just take my normal curve again. Okay, so we know that the mean is 25 minutes, and we want to find the probability that he takes less than 23 minutes. Let's work out for one bicycle first. So this is 23 minutes, it's below the mean. So we need to find this area over here. Okay, so that's the probability that the time is less than 23, which is, if we standardize that, is a probability that z is less than, so you take the score, subtract from it the mean, divide it by the standard deviation, which was 4. So this is going to give the probability that z is less than, that's minus 2 over 4, so it's minus 0.5. Okay, so the standardized score here is negative 0.5. Now there's a problem we have here, is that none of the z values give us negative. They're all positive. That's because the Z values start from this point here and they go to the right. Okay, so all the Z values we have are starting from this point here and they're going this way. Okay, so that's the problem that we're facing here. Alright, so we need to find the probability that Z is less than minus 0.5. So we have to go to minus 0.5. Let's say it's over here. Okay, just say it's over here. Negative 0.5. So we need to find this area in this section over here. But we can't look up minus 0.5 because it's not here. So what do? Well, what we can do is we can realize that this is symmetrical. If I go to Z equals 0.5, which is going to be on this side somewhere, okay, then because of the symmetry, this area here will be identical to the area that we need. Okay. However, if I go to Z equals 0.5, which is somewhere, actually somewhere quite convenient at the top here. If I go to Z equals 0.5, I get the value 0.6915. Now that is the area to the left of this 0.5. That's the area from here all the way up to there. That's 0.6915. But I don't want this area. I want the area to the right of it because that area is the same as the area that we need. So if I do 1 minus 0.6915, I will get this area that I need, which is the same as this area. Okay, so that's how we can deal with negative values which are below the mean. Okay, values where the standard deviation is below the mean. So I'm going to do 0.6915 is what I get from the table, and 1 minus that is what I need. Okay, so let's just write this out in a proper way. So the probability that Z is less than minus 0.5 is the same as the probability that Z is greater than 0.5. It's the same as I mentioned here. It's the same as the area on this side. Okay, these two areas are the same. And the probability that Z is greater than 0.5 is the same as 1 minus the probability that Z is less than 0.5. Okay, and that's what we found in our table, which was I forgot it already, 0.6915. 0.6915. Okay, so it's 0.6915. Okay, so if we do 1 minus that, we should get what we need. So we have 1 minus 0.6915, and that gives me 0.3085. 0.3085. So the probability that he takes less than 23 minutes on one bike, the less than 23 minutes on one bike is equal to 0.3085. Okay, and now we want to find the probability that he takes less than 23 minutes on each of the 3 bicycles. So there's 3 bicycles. So that means for the first bicycle and the second bicycle and the third bicycle, he has to have the same probability. So for the first bicycle, it will be 0.3085 times 0.3805 times 0.3085. So if you cube that, you'll get what we need. So we take this value and we raise it to the power of 3. And we get our answer 0.0296, 0.02936, 0.029, was it 36? 936, yeah, 36. So that is the probability, okay, that we need. The probability that he takes less than 23 minutes. You know, basically, you got to cube that 3 times, one after the other. So that gives us the answer of 0.0294 to 3SF. And there we have the answer. Now, you'll notice in the mark scheme for this particular paper, this Solomon paper, this last question, they have got it wrong for sure, because they have used this value here. They have taken 0.6915 and they have cubed that. And 0.6915, you can see straight away, it's the area from this point here, which is actually going to be less than 27, okay? Because its area is more than a half of the whole area. If we want to find the probability that it takes less than 23 minutes, well, less than 23 minutes is going to be less than half the area, see, because it's this small part here. So there's no way that you're going to take 0.6915 and cube it to find the time taken less than 23 minutes 3 times in a row. So that's definitely wrong. Okay, so they forgot to take away this from 1, and that's why the answer is not the same. This is the correct answer. Okay, and that's the answer to part C, and that's that question answered from question number 5 from the Solomon C paper. Thank you for watching, and I hope to see you soon. If you want to see other questions from the Solomon C paper, you can click on the link that will appear on this part of the video, and you can click down here to find links to other questions about normal distribution from S1. Subscribe to my channel from this link, and at the top of the page you can get a card which will take you to one of my S1 past papers. Thank you for watching, and see you soon.